right, here we go. We are on example number 4. And we're going to, where's my graph? Did yours have a graph? Did your graph print out on your notes for number 4?
Yeah.
All right, pretend that you see my graph because apparently I deleted it. I don't know. I'm concerned. Anyways, the graph that you do not see, but you do see on your notes, which is what's most important, contains the points -5, 12, and 6/2. Okay. Also, when you look at this graph, you can see that there is some type of curve happening, right? So that lets us know that it's concaved up. And so we have it where it could be some type of polynomial or an exponential, right? Yes. Okay. So what we're going to do is we're going to go through the process to write the exponential function that best represents this given the 2 points that we have. Okay. This is not using a calculator. This is using your big brains that you have. Here we go. So first we're going to talk about what is the standard form for an exponential model. That is y equals a times b to the x, right? That is our standard form. Y equals a times b to the x. The goal here is to figure out what is a and b. So we got to try to figure out what is a and b, and we're going to do that by using the given points that we have and approximating the value of b, as in Bob. Yes. There, we'll do like a little mini introduction in May. But oh, okay. I thought you were like hoping and praying.
Yes.
All right. So, how many of you guys remember systems? You remember doing system now, number 2?
Like plug it in and then plug it in.
Yes. So a system is saying you are trying to find a solution to one or to 2 or more equations, right? Where they meet, what values make them true, correct? That's essentially what we're creating here. We're going to create a system, okay? Our system is based off of, remember, don't make fun of my braces. They do what they do, okay? Just accept my braces. Okay, to create our systems, we're going to be using our given x and y's from our table, our graph. And we're going to substitute them in for x and y in our standard equation. Okay, so our first equation that we have, y is 12 equals a times b to the -5. Okay. On our next one, we're going to be using 6 and 1/2. So 1/2 is our y. We do not know a nor b, and our x is 6. So all I did was plug in the given x and y's to our standard equation. Do we see that? Because that's all I have. I don't know anything else. I just know what x and y are. Okay. These two come from the same a and b. Our job now is to find the a and b. Does that make sense? All right. So when we solve systems, we learn 2 methods. We learn substitution and elimination. Ringing bells? We can't use elimination here because there's nothing being added or subtracted. So our only option is to use substitution. Okay. In order to use substitution, that means we have to choose one of these variables to isolate and plug into the other. So if I chose to isolate a, right, this is going to lead to a equals 12b to the 5th power. It's a negative. We divide. It's multiplication.
-5 would fit underneath a.
Exactly. It's a division. There's no addition or subtracting happening. All I need to do. This right here is really, let's rewrite. B to the -5 equals 1 over b to the 5th. So to move it, it becomes like Andrew said, b to the 5th.
Is it 1 over the 5th times a, or is it a over the 5th?
It doesn't matter if their a is in front or on top.
Is that
It's implied multiplication either way. This is something you don't write down.
oh, right.
All right. So, remember b to the -5 means that the b is actually in the Where? Denominator, Miss Jones. Yeah, that's what we all said, right? Yeah, it's in the denominator, Miss Jones. Okay, because my power is negative, that means that this number, this expression belongs in the denominator. So if you are wanting, if this, how it's written bothers you, you could rewrite this as, I'm gonna rewrite it. 12 equals A divided by B to the 5th. So what would I need to do to get A by itself? Multiply by B to the 5th, which is why Andrew said A equals 12 times B to the 5th. Yes, you did. Okay, so what's wrong with y'all? Okay, all right, so now I have a value that I can substitute in. Does that make sense? I'm gonna plug that in for A, and now I'm gonna solve for B. So we have 1/2, but instead of A, we're plugging in 12 B to the 5th times B to the 6th. We're gonna clean this up. What do I do with the B to the 5th and B to the 6th? I combine the powers through what operation? Addition. So I'm adding these two together. So I'm left with 1/2 equals 12. No, it's not. 12 B to the 11. 5 plus 6 is 11. Okay, and now our job is to get B by itself. What did I do to get B by itself? Divide by 12.
1 out of 4.
It's what?
What?
What is 1/2 divided by 12?
24.
What kind of 24?
124.
124. Okay. When you multiply fractions, you would take the 11th root. Yes, it's exactly what we're going to do, Anna. We're going to take the 11th root. So when you multiply fractions, remember you keep, change, flip. So in your brain, you have 1/2 times 112, which equals 124.
Oh, okay.
Okay, like Anna said, B is not by itself. To get B by itself, we are literally taking not the square root, the 11th root. So we're gonna go to our handy dandy calculator. Let me open Sylvie. Here she blows. You're gonna press math. There you go. You're gonna press math, and you're gonna go to where your radical has an X. That allows you to type in whatever root you need it to find. We need the 11th root of 124. What is the 11th root of 124? 0.749. 0.74. I'm just going to stop at 0.749. It's a little more accurate to 3 decimal places. So now we know B. So B equals 0.749. Now that I know B, I can substitute that in and solve for A. So here I'm doing 12 times, and I'm going to put 0.749 to the 5th power. And that's going to tell me my A. What is A?
2.82.
There we go. A is going to equal for us approximately 2.829. Sylvie, please move to the other side. Thank you. All right. Can I write my equation now? Okay, then and therefore, that's what these little 3 dots mean. Or in conclusion, I'm playing. Then and therefore, y equals approximately 2.829 parentheses 0.749 to the x power. Now that I have a function, can I evaluate? Yeah? All right, find the y-intercept. I've given you a function. Please find my y-intercept and do it quickly. It should go real quick, guys.
It's literally.
Thank you. There we go. I was like, guys, it should go real quick. I was waiting for this. All right. So if we need to find our y-intercept, so we're looking at y at 0, and that should be what? 2.829. And why is that? Anything to the power of 0 is 1. So this is our y-intercept. So our y-intercept is 0, 2.829. Yes? Could I evaluate anything else from here also? What if I need to know what? Huh? What'd you say? Asymptote. Well, the asymptote is still at 0 because we are in standard form. 7. Could I plug in and find 7? X equals 7. No, we don't. But I just want to make sure that we are comfortable that the purpose of the equation is now that I can make predictions with given values, correct? All right, cool. Tell me, how is it? Terrible, doable? I knew it. I knew you were going to say that. I knew all those things. All right, next, here we go. Real world example time. This is an example of a possible way that a free response could be set up on this topic. Does that make sense? So if we're looking at example number 5, this is an example of a possible free response that you could get. Make sense? Okay, so a chemist has 100-gram sample of radioactive substance. The table below shows the amount of radioactive material at the end of the week for 6 weeks. Okay, use a graphing utility to find an exponential function to the data. Write the equation for the data. All right. Now, when we look at this, we can kind of make some assumptions depending on whether you're going from the beginning to the end on which 2 values you're going to use to find your A and your B. Okay. So in my mind, what I was taught is if you're doing it by hand, you start with your least to your greatest. So we would be using 0 and 100 and 6 and 44.2 to help us find our A and our B and going from there. Okay. In part B, if this is given as a calculator question, you're going to be able to do it completely with a full-on calculator and have a better example. Okay. But are we ready to go through the steps that we just did? Okay. So here we have from 0 to 100, 6 and 4, from 0 to 6 as our weeks. We're going to look at 0, 100 and 6 and 44.2. And you're going to repeat what we just did to find your A and your B. Okay. Are you willing to do it on your own first?
Yeah.
Okay. I believe in you. So we're going to start off here. And we're going to end here. Following what we just did. Remember, the standard form is y equals A times B to the X. You should be trying. Huh?
Or not even. Well, I remember when in Algebra, made us do like all